Hello students. So in the previous video, we had seen a very important criteria for similarities of triangles, that is AAA criteria, isn't it? Now this AAA criteria can be further shortened and said as AA criteria. Okay. So what we saw in the AAA criteria was that three angle in one triangle, if it is equal to three angles in another triangle, then those two triangles are similar, right? So we need not check for three angles. If we check whether two angles in one triangle is equal to two angles in another triangle, then automatically we can say then the triangles are similar. For example, let's take two triangles. Let's say the angle here is 40 and let's say the angle here is 60. Let's say the angle here is 60 and let's say the angle here is 40. Now, if you observe, two angles here and two angles here are equal. 60 is equal to 60, 40 is equal to 40. Now, the third one, will it be equal or not? Definitely it will be equal, isn't it? So 60 plus 40 is 100. This will come out as 80. 60 plus 40 is 100. This will also come out as 80 because angle sum property. If you add the three angles of the triangle, it will give you 180 degrees, isn't it? So here we didn't know whether the third one was equal or not, right? Earlier, we didn't know whether the third angle is equal or not. Since the two angles are equal, automatically, definitely this angle will be, the remaining angle will also be equal. So from now onwards, whenever we are trying to prove two triangles are similar, we need not check for three angles. It is enough if we check for two angles. That is, if two angles in one triangle, it is equal to two angles in another triangle, we can say those two triangles are similar. Okay. So this is what we are going to use in solving the problems, AA criteria. That is two angles. Now the other two criteria are SSS and SAS. So SSS and SAS, let me take two triangles and explain. PQR, or let me take DEF itself. DEF. Now suppose the ratio of AB by DE and BC by EF and AC by DF. If the ratios are equal, suppose this side by this, any side, I mean, it's not necessary that we have to take the left side with left side itself. Okay, for our understanding, we are taking like that, so that will be easy. But it's not necessary that if you're taking the left side, left itself, the bottom with bottom itself. It's not like that. You can take ratios with any side. You can take the ratio of this side with this. You can compare AB and EF, BC and DF, however you wish, but the ratio should be equal. We'll be seeing such a question in the exercise where we'll get to know that we need not take like this itself. However wish, we can take the ratios, but we have to get the ratios as equal. Even after trying it out all the manner and still we are not getting the ratios as equal, then we can say the triangles are not similar. We have to try all the possible ways of finding the equal ratios. Okay. Now, if this condition is satisfied, that is three sides in one triangle, three sides in another triangle are in proportion, then I can tell these two triangles are similar. Also, I can tell the corresponding angles are equal. That is, how do you find corresponding angles? Very simple. Compare the numerator, which is the alphabet that is same, B. Here, compare the denominator, which is the alphabet that is same, E. So B will be equal to E. Again, compare these two numerators. C is common, F is the same alphabet. So C will be equal to F. The remaining one, A, will be equal to D. Do you remember in the previous video that we started with this criteria, isn't it? We started with this criteria, that is three angle in one triangle is equal to three angles in another triangle. We ended up here, right? In a similar fashion, we can prove, using this, we can prove these result. Okay. So if three sides of one triangle and three sides of another triangle are in proportion like this, we can say two things. One is the triangles are similar, also the corresponding angles are equal. Okay. Now what is SAS? the SAS criteria is that one angle should be equal. One angle should be equal. Let's say like this. One angle should be equal and sides containing those angles, that is, this angle is between what? AB and AC. This angle is between what? DE and DF. This AB and AC, DE and DF should be in proportion. That is, if you take ratio of them, AB by DE, AC by DF, they should be equal. One angle should be equal and sides containing those angles, that is AB, AC, DE, DF. If you take the ratios of them, you can take however you wish. It's not necessary that I have to take AB with DE itself. I can also take the ratio of AB with DF and AC with DA. But the thing is, the ratios should be equal. If the ratios are equal and one angle is equal, therefore we call the triangles to be similar using SAS criteria. Now we'll conclude all the criteria that we have got for similarities. Totally we have got 3 criteria. That is AAA, SSS and SAS. So AAA, SSS and SAS. These are the 3 criteria to prove 2 triangles are similar. Okay. Now, very important note. If 2 triangles are similar, then we can say corresponding angles, out of all the things that we discussed, you have to remember this point. Okay, corresponding angles are equal. Corresponding sides are in proportion. Corresponding angles are equal. Corresponding sides are in proportion. That is, remember, whenever we have 2 similar triangles, if we have 2 similar triangles, we can also conclude these 2 things. And suppose if we have triangles, if we have 2 triangles in which this condition is satisfied, then definitely this and this will also be satisfied. If any one is there, the other 2 will be there, definitely. If this is there, these 2 things will be there. If this is there, these 2 things will be there. Or if this is there, this and this will be there. Okay, so we have to remember these 3 things. Out of these 3 things, if any one is there, if any one is there, in the sense, if any one is satisfied, the other 2 are also satisfied. If triangles are similar, I can say these 2 things. We can also say these 2 things. Or if corresponding sides are in proportion, we can say corresponding angles are equal. Also, we can say the triangles are similar. Or if corresponding angles, or let's say corresponding sides are in proportion, then we can say this stuff and this stuff. Okay, so remember this point. If any one is there, the other 2 can also be used. Okay, now we'll start with the exercise problems of triangles, that is similarity of triangles. Okay, in the exercise, that is the third exercise of triangles chapter, the first question, they have given us triangles. In each case, we have to find whether the triangles are similar or not. If similar, we have to mention the criteria. Okay, let me do it here itself. Now, in the first case, we have given triangle ABC and triangle PQR. Okay, now before trying to prove or trying to check whether the triangles are similar or not, let's recall the important criteria which we did right now. That is, AAA criteria is one thing, SSS criteria is one thing, SAS criteria is another thing. Totally, we have 3 criteria which can be used to prove the triangles are similar. Okay, on that note, let's start the first question. The first question, if we observe, in triangle ABC, we have got 60 degree. In triangle PQR also, we have got 60 degree. So 60 degrees here, 60 degrees here. Now, we have also got 80 degrees we have also got 80 degrees, and we have also got 40, and we have also got 40. We need not check for three angles. Actually, two angles are equal, then automatically we can say that directly we can say that triangles are similar. Therefore, these two triangles are similar using AA criteria. Okay, so let's get into the next one. If you observe the question in the next, that is, they have not given any information regarding the angles. Therefore, we must use SAS or SSS. Again, SAS cannot be used because there is no information about the angles. They have given only the measurements, that is the sides length. Okay, so which means we have to check the SSS criteria. Okay, let's find whether the ratios of the sides are equal or not. Okay, usually what we do is, let's start the same logic. If you observe this side, let's take the ratio with this one. So let's say this is 5 centimeters and this is 2 centimeters. So 5 by 2 gives you how much? 2.5, isn't it? 5 by 2 gives us 2.5. So okay, let's take the bottom one with the bottom one itself. Okay, 4 by 2.5. 4 by 2.5, it will become how much? Let's do that. 4 by 2.5. So if you remove the decimal, it will become 40 by 25. 40 by 25 is 8 by 5. Okay, so the ratio is not equal because 5 by 2 was 2.5 and 4 by 2.5 is something else. So the ratios are not equal. Now just checking like this, and since the ratios are not equal, you cannot come to a conclusion that the triangles are not similar. Okay, what I'm trying to suggest or say here is, we have to find the ratios in all possible ways. Okay, now if you observe carefully here, this 6 centimeter and this 3 centimeter, let's take the ratio. 6 by 3 is how much? 2. 6 by 3 is 2. Let's take this 4 with this 2. 4 by 2 is how much? 2. Let's take the remaining one. 5 by 2.5. That is also 2. So you have to check the ratios in all the possible ways. Now, even after checking in all possible ways, if the ratios are not equal, then we have to tell that the triangles are similar. But earlier, I took a ratio where we didn't get equal, but I tried another way. I got the ratios to be equal. Therefore, we can tell the triangles are similar. Okay, let's take the other triangle. Okay, in this triangle, if you observe, this is 3 and this is 6. DF is 6. Take the ratio 6 by 3, it becomes 2. Again, 5 by 2, it becomes 2.5. Okay, 6 by 3 is 2. 5 by 2 is 2.5. It is not equal. Okay, let's try some other method. I mean, some other ratio. So let's try different ratio. Let's take this 3 with this 4. 4 by 3 or 3 by 4, and this 2 by 5. So what we have got is 3 by 5 and 2 by 4. Definitely 3 by 5 and 2 by 4, 3 by 4 and 2 by 5 are not equal. You can check it out. 3 by 5. You try the ratio in any possible manner for the third one, any possible manner. You will never get the ratios to be equal. Okay. Therefore, we can conclude that the third one, the triangles are not similar because they don't satisfy the SSS condition. Okay, coming to the fourth one. In the fourth one, if you observe, there is one angle given. So, which means we have to make use of SAS. So, one angle is given, 70 equals 70. Okay, the sides containing the angle are 5 and 2.5 in triangle MNL. In triangle PQR, it is 5 and 10. If you take the ratios, definitely it will be equal. Let me take the ratio of this 5 divided by 2.5. 5 divided by 2.5 is 2. Similarly, 10 divided by 5 is 2. Okay. So therefore, the ratios are equal and the angles are equal. Using SAS criteria, we can tell that the triangles are similar. Okay. Now, let's go to the next one. in the next question, that is sixth one. Let me clear all the drawings. Okay, now coming to the fifth one and the sixth one. Let's do the fifth one. If you observe, one angle is equal 80 degrees and 80 degrees. Now, but there is no information about the side containing the angle. AC is the side containing the angle, right? So this angle is between AB and AC. They have given the value of AB, but they have not given the value of AC. Only if the value of AB and AC is given, we can check whether the triangles are similar or not. Okay, therefore the triangles are not similar because the adequate information is not there. Okay, so the triangles are not similar. Let's get into the next one. The E, if you observe, you got 70 and 80. So one angle is equal, 80 degrees, 80 degrees. But the other angle is not equal. We should not come to a conclusion that the triangles are not similar. Let's find the third one and then let's conclude it. So 30, the third one is how much? 80, 30 becomes 110. So the third one becomes 70. So here you will have 70. Here 78 is 150. The third one here is 30. So if you observe now, all the three angles here and all the three angles here are equal. Therefore, the triangles are similar using AAA criteria. Okay, students. So in the next video, we'll continue with some more problems. Now we'll stop here. Thank you, students.